Welcome back to Watergum Online and our online catchment crawl. We're going to take you on a virtual tour of some of the most interesting and innovative environmental projects that are going on the Gold Coast right now. Right, let's get going.
Hi, my name is Marjolein Oram, or everybody calls me Mars. I work for the City of Gold Coast. I'm a Catchment Management Officer and I look after the Coomera River catchment. We are here at the Coomera River and I want to talk to you about our Damian Leeding Stabilisation project, which we've done here at the Coomera River to stabilise the bank. Okay, so what is the Damian Leeding Stabilisation project? It is a way of using a naturalised approach to stop the erosion on the foreshore and on the bank and protect the park from failing. There were several stages to this project. First we had to do the design, and once we had the design, the construction of the foreshore and in-stream works that you see behind me started first. And once that was all done, the vegetation of the bank followed. So where we're standing here, this is where the footpath used to be. We had to move it into the park, otherwise it would have fallen down. That was another tip for us to really do some works here. It all creates that habitat for the species in the water column, but also underneath the sediment. Well, often you see rock walls, which is a way to quickly fix erosion, but we wanted to take a different approach, a more naturalized approach, whereby you not only stabilize the bank and make it safe, but you also provide healthy ecology to the river and for the water quality as well. There's a myriad of fauna that's using this site here now, and it's just all these benefits to mangroves, fish, crabs, crustaceans, birds, what have you. The list goes on. So this is how it works. These in-stream structures slow the water down when the water hits the foreshore, either from boat wash or from flooding flows. The sediment drops out and starts to build back up onto the foreshore and behind the logs. And that's what we want. We want this gradient of the bank to be of a more stable slope than what it is now. What we did was talk to our planning section to see if there was any development going on whereby trees had to be removed. And lucky enough, not far from here, actually where the Coomera Westfield shopping centre is now, a whole heap of trees had to be removed. The developer was kind enough to let us take the trees. We picked the ones that were big enough and tall enough for our project. As you can see, the root ball had to stay intact. We wanted the root ball part of it, not chopped down. and the root ball is facing upstream. So any floods that come down hit that root ball first, which create all these eddies and diversions of the floods towards the deeper end of the river, saving the bank from all that force. What we've used is a single log closest to the bank. They're tied onto two piles, one on either side, and then we've got a set of two logs tied onto one end together, and the end of the logs can actually move around slightly and drop into the lowest part of the riverbed. We had to deal with the bed erosion as well as the bank erosion. So the bed erosion is being fixed up by these two logs here. They're going all the way along, and we find that the sedimentation is starting here in the deeper logs, and once they're covered by the sediment, they become a stronghold in this river, and it's just going to provide that erosion protection for years to come. This single log here has got a different function. It stops boat wash directly hitting those little mangroves here, and they won't be stabilized anymore. They can grow into big trees because they've got the protection from the log. So basically when the water hits it, it changes direction, goes back into the deeper part, and it slows the flow. It also stops directly hitting the foreshore and the bank, and the scour is no longer occurring. So to be able to make sure that those hardwood trees weren't going to float away, we had to somehow tether them into the river. And these hardwood marine piles is what we've used. They are treated. We had to treat them, otherwise the marine worm, called the teredo worm, would just have eaten it out almost within a year's time. So it has been a bit over-engineered because the M1 bridge is just downstream. Just having a look at these logs here, there's these things here. They have been put there again to minimize risk should we have such a crazy flood that this big tree log might lift over the top of this pile. We really don't think that's going to happen. The engineer that's designed it doesn't believe it's going to happen because these big trees are very dense. We've picked eucalyptus, ciderfolia, any of those trees have got a very, very high density. That doesn't mean that they're really heavy, well they're heavy too, but they really sink in the water and not going to float. And the longer of course they are in the water and get saturated, the more less chance there'll be that they will ever float away. This here is an example of a long stem planting technique. We've used the hibiscus tiliaceus, which is a native hibiscus that grows well in estuaries and along the foreshore. And what we did is we grew them in the nursery till about 90 centimeters tall, still in a small little pot, then planted into the ground on an angle. We used a drill, make the hole, and then filled the hole back in again. So the idea is with the long bit that's in the bank, the roots can really try and hold that bank together. So here's an example of the same plant, the hibiscus tiliaceus, and that's starting to grow really, really well. All these fallen trees are becoming part of fish habitat, and that is protected under Fisheries Act. So what we did when we put the structures in, those big logs, we put them on top of, we dragged the trees and put the logs on top of them so that they wouldn't flow away from the sides. So all that nice fish habitat remains in this area. So what we're looking at here is all organic debris. It's the breakdown of all those trees that have fallen over the past many years. And might look a little bit messy, but messy is good. Messy also creates a roughness, and the roughness is something that slows the water down as well. These trees will break down eventually as well, and because of our logs here, most of this sediment will remain on the side. The other thing that's very, very typical is that the mangroves, they're just growing underneath and behind this roughness and these fallen trees. Anywhere where there's a bit of protection for them, they just pop up. You can see a little one here. It's just astounding how easily it has transformed. And it's the mangroves really that are going to create the foreshore stability. So phase 3 was the revegetation of the riparian foreshore. As you can see, it's growing quite well. We used a mixture of trees and low species like club rushes, lomandras, blady grass, just to allow a bit of a vista of the river still. Once these trees have grown up, people will be able to see to the river, and that connection to the river will be back to what we want to achieve. Our 5-year monitoring program looks at the profiles of the bank. We basically use a dumpy level at the top of the bank, staff down here, and we measure the bank and the foreshore each year. So what we want to see is an increase of sediment along the foreshore here, and we want to see that bank becoming less vertical, so more of a gradient that doesn't erode as easily. That's what we're aiming for, and that's what we're measuring for each year. Our monitoring program includes mangroves, of course. So we look at the biodiversity, how many different species we're going to find, and we look at the health. So we actually count the leaves and compare that to previous years, and we look at the height as well. And of course the density, how many we're finding here. Each year we're hoping to find more. We also have control sites. So we've got a control site downstream, and a control site upstream that are very similar to this. They're in the same river. They've got the same exposure to the flooding and the boat wash. And then we can compare it and say, we've had so much more success with the mangroves at this site compared to the controls. And then we can basically say, yeah, this is working. It's a successful method and treatment to use. So what we found so far with the mangroves, we sampled them in 2 consecutive years, that there was a significant increase in mangrove growth in the treatment sites. And also with the bank, it is still stabilizing, so it's still not quite the gradient that we want to see, but we are definitely seeing an improvement to what it was before. And around the logs and at the foreshore, we see an increase of sediment as well. And one of the most rewarding benefits of this project has been the wildlife. The amount of birds are starting to use this site is amazing. We also see fish everywhere, and even stingrays come in between the logs. We see the indentations from where they've been resting and feeding. Crustaceans are growing onto the logs, and yeah, it's just amazing. It's really good to see. So the Damian Leeding Stabilisation project is 450 meters in length. It is part of a 2.5 kilometer riparian foreshore restoration project. From the beginning of the park of Damian Leeding Memorial Park, it goes upstream and around the corner to another park called Regatta Parklands. The Kumar River Catchment Group is working very hard in there to plant many trees along the 60-meter wide riparian zone that we've got there. So once this is all done, we've got a really good protection for the river, for the Kumar River, plus great ecological benefits for them as well. So thank you to the Kumar River Catchment Group that have planted thousands of trees already, and those parklands will open to the public eventually. If you want more information on this project, come down to Damian Leeding Memorial Park or look on the Gold Coast website and search for Damian Leeding Stabilisation Project. Thank you.